Welcome, students, to this lecture on expert systems. My name is Professor Gregory Wanyembi from the School of Computing and Informatics of Mount Kenya University. In today's lecture, we have the following objectives. One, to define the term expert system. Secondly, to describe the areas of artificial intelligence. Thirdly, to differentiate between problem domain and knowledge domain. Fourthly, to discuss the advantages of expert systems. Fifthly, to describe the stages in the development of expert systems. Sixth, to examine the features of an expert system. And seventh, to examine the structure of a rule-based expert system. And finally, to discuss the applications of expert systems. What is an expert system? Well, I'll prefer to take this definition from Professor Edward Feigenbaum from Stanford University, who described or who defined an expert system as a computer system that emulates or acts in all respects with the decision-making capabilities of a human expert. Well, he's a professor like myself, and therefore I make use of his definition of an expert system. What are the areas of expert systems, of artificial intelligence for it? We have a number of areas that constitute artificial intelligence, and they range from vision, computer vision, to natural language processing, to understanding, expert systems, artificial neuron systems, speech, and robotics. So these constitute the areas of artificial intelligence, and as you can see, expert system systems are actually a very important area of artificial intelligence. What are the main components of an expert system? Well, what are the expert system technologies? We have quite a number that have been developed, and they include expert system languages like CLIPS, perhaps you may have heard of this, Prolog, and Lisp. They are the languages that are used in developing expert systems. Programs are normally written in these languages, and that there are special hardware that are designed to facilitate the implementation of these systems. These ones are also provided. The main components of an expert system. There are two main components of an expert system. One is called knowledge base. Really is a collection of special or specialized knowledge in a particular area, very narrow area. They are obtainable from books, magazines, reports, and knowledgeable persons that we would want to refer to as the domain experts or human experts. The other component of an expert system is the inference engine. This is the engine or the part of a computer system of the expert system that draws conclusions from the knowledge base that is stated up there. This diagram shows the two components of an expert system. That is the knowledge base at the top there, and then the inference engine below it. The whole thing is known as an expert system. And you as a user of this expert system will want to enter facts into the expert system, perhaps queries, and after the expert system has considered those facts and queries, it will be able to draw conclusions and communicate them to the user in the form of expertise. If it is an advice, it will give you that bit of advice. Now, there are these two areas that we need to distinguish. That is the problem domain and the knowledge domain. An expert's knowledge is fairly specific. And when we say an expert, it means somebody knowledgeable in a very narrow area, indeed. But he has vast knowledge about that particular area. So it's very specific to one problem area. And normally we use the term domain to indicate that. Therefore, we may have an area like medicine, even within medicine only a very narrow area, or in finance, or in science, engineering, surgery, management, planning, many areas that can be applied. Then the expert's knowledge is about solving a particular problem in using particular methods or techniques, etc. And this is referred to as the knowledge domain. So the two domains, there is the problem domain and then the knowledge domain. The two are related somehow, that the problem domain is actually the superset of the knowledge domain. If we look at this diagram next, you will see what that means. That we have in the world a lot of problems. Some are simple, others are complex. But then there is only one domain that is perhaps solvable by having some specific knowledge about that particular area. So the problem domain is a superset of a knowledge domain. Now, what are the advantages of using expert systems? They are numerous, and we'll just go through a list of them. One is increased availability, because as an expert system, it is a software, really, which is available, and it can be available at all times. Also, reduced cost. Reduced cost in the sense that, well, compared to a human expert costs a lot to produce. First of all, it's got to go through a long period of training, a long period of maybe working, gaining experience, and all the rest of it. But with the expert system, you can code that as a system, and once you've done it, you can replicate, get many copies of the same. And therefore, there is the element of reduced cost. Also, reduced risk, increased performance, multiple expertise, as well as explanation facility. An expert system should be able to explain its decisions or its advice. Also, they are very fast, so the response you get is usually very fast. Steady. Expert systems are very steady, unlike human experts who can become ill or perhaps tired. They are unemotional, though they are not subject to emotions like human beings are, and they give complete responses at all times. They also have intelligent database, etc. So there are numerous advantages of having an expert system. Now, representation of knowledge. How do we represent the knowledge possessed by a human expert in an expert system. Now, there are very many, there are several ways of actually representing human knowledge in an expert system. This one can be represented in a number of ways, including what we call if-then rules of the first order logic. For example, a statement like this one: if you are hungry, perhaps as you are now, then obviously to solve that problem you have to eat, isn't it? Correct. So these kind of rules are the ones that are used to represent that knowledge. Now, there is another process that is very important to note, and that is knowledge engineering. This is the process of building an expert system, and it involves the following three steps. One, that the knowledge engineer will establish a dialogue with the domain expert, meaning that they establish a kind of communication between themselves, the knowledge engineer on one hand, and the human expert on the other. This is merely to elicit or to obtain the knowledge from the human expert. Then the knowledge engineer, this person who actually engineers or creates or develops the expert system, will code all the knowledge that he has learned from the human expert, will code that knowledge and store it in what we call a knowledge base, which we saw a little earlier. And then the human expert will look at what the knowledge engineer has coded, see how the whole system works, and will evaluate that expert system to give it a critique. So there are those three steps involved in the process of building an expert system. This diagram depicts that process. That one, we have a human expert over here, represented by that box. We have a knowledge engineer in between, who then establishes a dialogue between the human expert and himself or herself, and then the knowledge engineer using his expertise in writing programs to create a knowledge base of an expert system. Of course, this is evaluated by the human expert to see whether or not it's done the right thing. And so this is the process of developing an expert system. Now, why do we need, and what was the motivation for creating or for developing expert systems? Well, this arose fairly early on in the history of computers. That originally, algorithms were used to solve various types of problems, particularly numerical ones: adding, subtracting, multiplying, searching, sorting, and etc. But then, computer scientists at that time realized that there were other categories of problems that could not be solved by using algorithms alone. An algorithm is simply a step-by-step procedure for solving a problem in finite amount of time. When these algorithms are either not available or they are insufficient or inadequate, then the solution would be artificial intelligence. Examine a human being, look at the way he solves problems, and try and create a system that will emulate that human being. Hence, the creation of artificial intelligence, to look at those problems that cannot be solved by using algorithms. So expert systems here rely on inference engine, which draw conclusions, as we have already said, and then they provide what we call not precise solutions, but what we would say acceptable or reasonable solutions. Now, this is because knowledge is or can be broadly divided into two. Knowledge as we know it. One called shallow knowledge, the other one called deep knowledge. Shallow knowledge is the knowledge that is possessed by almost everyone, everybody, yourself, myself. Therefore, very many people can claim to have what we call shallow knowledge. After all, it is the one that enables them to interact, do things, etc. But then there is another category of knowledge called deep knowledge. Deep knowledge, on the other hand, is that possessed by very few people. We refer to as human experts. Now, algorithms can solve problems in this area, shallow knowledge, but they cannot solve what we refer to as deep knowledge. So the solution to these kind of problems that are to solve problems in this area is to create artificial intelligence. Artificial intelligence, and more so expert systems, are meant to solve problems that are possessed by expert systems. What are the limitations of expert systems? Well, we can note two of them. One is that the expert systems cannot generalize through analogy to reason about new situations in the way that human beings can do. And secondly, there are knowledge acquisition bottleneck results from a time-consuming and labor-intensive task of building an expert system. What examples do we have from history of expert systems that have been built? Yeah, early expert systems included one called Dendro. This one was used in chemical mass spectroscopy to identify chemical constituents. Another one called Mycin. This one was used in medical diagnosis of illnesses or diseases. Deep meter, this one was geological data analysis, expert system for oil exploration. There is also another one called Prospector. This was also a geological data analysis for minerals this time. This one is for oil, and this one for minerals. Also XCON, this one was used in configuring computer systems. What are the features of an expert system? An expert system commonly has a number of features. They all have what we call a user interface, which provides facility for the user to interact with the expert system. And then we have an explanation facility. This one explains the reasoning of the expert system to the user. Then we also have a working memory, which is a global database of facts used by the rules. And then the inference engine, which you have already mentioned, which makes inferences deciding which rules are satisfied prioritizing them. more features. Agenda. Yes, this is a prioritized list of rules created by the inference engine whose patterns are satisfied by facts or objects in working memory. And then we also have a knowledge acquisition facility. By the way, expert systems are not created to be static. They grow in knowledge. So they continue acquiring new knowledge as time goes by. Therefore, they have this acquisition facility. It's an automated way for the user to enter knowledge in the system, bypassing the explicit coding by the knowledge engineer. And now we have what we call production rules. This is knowledge base, which is a knowledge base has another term used to refer to it, and that is production memory. And then production rules can be expressed in this if condition then action pseudocode kind of format. The rule-based systems, the inference engine, all these ones determine which rules are satisfied by the facts. And a structure of a rule-based expert system is as we now have it in this diagram, consisting of here the knowledge base with the rules. We have the inference engine with the agenda, which we have already mentioned. Here we have what we call a working memory with facts. And then below here we have an explanation facility, which is the facility that explains the reasoning by the expert system. And then a knowledge acquisition facility for acquiring new knowledge. As it is being used repeatedly, it acquires more and more knowledge. And of course, there is the user interface here, which enables the user to interact with the expert system. Now, let's finally look at the applications of expert systems. Expert systems have been found applications in many areas, not only these ones listed here, but many others as well. But first of all, we have what we call a configuration class of expert systems. These ones assemble proper components of a system in the proper way. Then we have those that dwell on diagnosis, which infer underlying problems based on observed evidence. We have those that are actually used for teaching. For example, you could have an expert system teaching you this lesson. Yeah. So instruction here, the intelligent teaching, it's an intelligent teaching so that a student can ask who, why, how, or what if questions that just as if a human teacher was teaching. Then we have those that interpret. They explain observed data. There are those that are actually meant for monitoring processes or systems. They compare the observed data to expected data to judge the performance. There are also those that are used in planning, economic planning, etc. They predict the outcome of a given situation. They devise actions to yield desired. And then there are those that are for prognosis. For example, we are now faced with corona virus. When is it likely to end? These kind of questions would be dealt with by an expert system in the prognosis. Also remedy, they prescribe treatment for a problem, and then there are those that are used in control systems. They regulate process and may acquire interpretation, diagnosis, monitoring, planning, and also prognosis as well as remedies. In summary, therefore, I would like to say that during the 20th century, the previous century, various definitions of artificial intelligence were proposed. In the 60s, a special type of artificial intelligence called expert systems was developed, and it dealt with complex problems that are normally found in a narrow domain. For example, in medical disease diagnosis. And in today, expert systems are used in a variety of fields, as we have already seen. They actually solve problems for which there are no known algorithms, where we don't have solutions using algorithms, then we revert to expert systems. Also, expert systems are knowledge-based, effective for solving real-world problems. And expert systems are not suited for all applications. So don't think of any area and say, okay, I'll try and develop an expert system for it. There are only a few areas. And then finally, future advances in expert systems will depend on the new quantum computers, perhaps new computers which will be developed, those with massive computational abilities in conjunction with computers on the internet. And with that, I thank you for listening to me.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.
Mwishoni mwa mwaka jana, homa ya virusi vya corona yaani COVID-19 imeibuka kuwa tisho kubwa la kiafya. Maambukizi ya homa hii yameenea ulimwenguni kote, wala hakuna aliye salama. Serikali kupitia idara ya afya imeweka mikakati, miongoni mwao ikiwa uchunguzi wa homa ya corona miongoni mwa wasafiri katika mipaka yake yote kote nchini.
I'm very happy about the screenings that are going on in Tanzania.